Hello guys, welcome back to the Roots of Unity. I'm Ittehad with the third video of differentiation. Today I'm gonna start off our video by showing you how to differentiate trigonometric functions. Let us consider a function y is equals to sin x. Now differentiating y is equals to sin x according to the rules of differentiation will give us cos x. If we differentiate cos x, it will give us minus sin x. If we differentiate minus sin x, it will give us minus cos x. And if we differentiate minus cos x, it will give us sin x again. We need to memorize all four of these formulae. Instead of memorizing all four of these formulae, I have an effective way to remember using the curve of y is equals to sin x. It starts at 0 and ends at 0 as well. Now, if we shift the y-axis 90 degrees to the right, the curve changes from sin x to cos x. The starting point is over here and not 0. Similarly, if we differentiate sin x, it gives us cos x. Now let us check it out once again. If we shift the y-axis 90 degrees to the right once again, the curve obtained is minus sin x from cos x. Similarly, if we differentiate cos x, we get minus sin x. If we shift the y-axis to the right once again, we see that the curve formed between the red lines is minus cos x. If we differentiate minus sin x, we get minus cos x. And same with the minus cos x. If we differentiate minus cos x, it gives us sin x, and between the dark blue lines, we see that a sin x curve is formed. Therefore, shifting the y-axis to the right once means that differentiating a curve of sin x or cos x or minus sin x or minus cos x once. This is quite an effective way to remember the formulae, but this can only be applied in terms of sin x and cos x. It cannot be applied while differentiating other trigonometric functions like tan x, sec x, or cosec x, or even cot x. Now let us see how to differentiate y is equals to tan x. We can write y is equals to tan x as sin x divided by cos x. From here, if we want to differentiate it, we need to use the quotient rule, since sin x and cos x are in the form of u divided by v. Here sin x is the u, cos x is the v. This is the formula we saw last class. We will put the values of u's and v's. Differentiating sin x will give us cos x, differentiating cos x will give us minus sin x. Cos square x plus sin square x will give us 1. We know this identity from the chapter trigonometry. 1 divided by cos square x will give us sec square x. Therefore, differentiating tan x will give us sec square x. Now, let us move on to our next topic, higher derivatives. The first question that comes into our mind is, what are derivatives? The differentiated result of a function of y, which is dy by dx, is the derivative of the function in terms of x. dy by dx is known as the first derivative. Similarly, if we differentiate the dy by dx again, we will get d square y by dx square. This is known as the second derivative. If we differentiate d square y by dx square again, we will get d cube y by dx cube. This is the third derivative. And it goes on and on and on until d to the power ny by dx to the power n. We really don't need that much. We just need to know till d square y by dx square. Now, for any function of y in terms of x, dy by dx, or the first derivative, represents the gradient of the curve at a certain point of x. Now, we know that for polynomial equations, we are often told to find the stationary points, which is also known as the turning points, and the nature of the turning point, whether it is a minimum point or a maximum point. We know that dy by dx is equals to 0 when the curve turns. Therefore, we can also say that the gradient of the curve is equals to 0 because it is parallel to the x-axis. We can use this property to find out the turning point. d square y by dx square, or also known as the second derivative of the function, is used to find the nature of the turning point, whether a curve is maximum, which means a sad phase, or minimum, which means a happy phase. If d square y by dx square is greater than 0, then the curve is a minimum curve. If d square by dx square is less than 0, then the curve is a maximum curve. That was all for this video. Stay tuned with the Roots of Unity for more contents of differentiation.